Hello friends, let us solve two more problems on quantization. The first problem is as follows. An analog signal is sampled at the Nyquist rate fs and quantized into L levels. Find the time duration tau of 1 bit of the binary encoded signal. So what is given in the problem is the sampling rate, which is equal to fs. So fs samples per second is the sampling rate, and each sample is represented by n bits, say, then the bit rate would be n fs bits per second, and the bit duration tau will be its reciprocal, so it will be 1 by n fs seconds per bit. Now the number of quantization levels L are given by 2 to the power number of bits used to represent a sample. So 2 to the power n, that gives n equal to log L base 2, and this quantity must be an integer because number of bits must be an integer. So we enclose it within brackets to show that n must be an integer. This n would be either the floor of log L or ceiling of log L, depending on other constraints given in a problem. Here we just take it to be an integer. Accordingly, the bit duration tau is equal to 1 by nfs equal to 1 by integer value of log L base 2 times fs. So this is the answer. Let us now look at the second problem. An analog signal is quantized and transmitted by using a PCM system. If each sample at the receiving end of the system must be known to within plus minus 0.5% of the peak-to-peak full-scale value, how many binary digits must each sample contain? So what is given in this problem is we have a PCM system in which we quantize a signal after sampling, and each sample must be known to within plus minus 0.5% of the peak-to-peak full-scale value. So let's say the peak value is m max, and at the other extreme the minimum value is minus m max, so that the peak to peak value is 2m max. This is the input signal m, and now the maximum error in PCM, assuming uniform quantization, is given by delta by 2, where delta is the step size, and this delta by 2 must not exceed 0.5% of the peak to peak value, which is 2m max. Remember, for uniform quantization, the quantization error is uniformly distributed in the interval minus delta by 2 to plus delta by 2. That is, the maximum positive error is delta by 2, maximum negative error is minus delta by 2. So the error is within plus minus delta by 2, and that should not exceed plus minus 0.5%. And therefore, delta by 2 is less than equal to 0.5 by 100 into 2m max, or from here, delta is less than or equal to is 0.02 m max. Now we further know that the number of quantization level L is equal to the dynamic range, the peak to peak value 2m max, divided by the step size delta. And because here we have an upper bound on delta, and that delta is appearing in the denominator here, we will have a lower bound on L. That means L must be greater than or equal to 2m max upon 0.02 m max. Now this m max and this m max cancel, and this is 100. L must be greater than equal to 100. The number of quantization levels must be greater than or equal to 100. But we know that the number of quantization levels L is equal to 2 to the power n, where n is the number of bits to represent each sample. So 2 to the power n must be greater than equal to 100. Right here, since L is equal to 2 to the power n, where n is the number of bits, or from here n must be greater than equal to log of 100 to the base 2, and this comes out to be 6.643, and n must be an integer greater than this number. So n is indeed the ceiling of 6.643, the smallest integer greater than 6.643, which is equal to 7. Thus, each sample should contain 7 bits or 7 binary digits. So that is the answer. I hope these two problems are clear to you. Thank you.